Why can your phone do millions of calculations per second? Why does a tiny chip decide whether your laptop turns on or stays off? And how can a material be an insulator one moment and a conductor the next? Welcome to Semiconductors, the technology behind every modern device. Take a small LED and connect it to a battery. It lights up only when you connect it in the correct direction. Flip the wires and nothing happens. That one-way behavior is the entire spirit of semiconductor electronics. A semiconductor is a material like silicon that doesn't behave strictly like a metal or an insulator. It sits in the middle, and the best part is we can control its conductivity. Heat it slightly, conductivity increases. Add impurities, called doping, conductivity dramatically changes. Apply a small voltage, electrons suddenly start flowing. Now we can build components that behave in very precise ways. Let's begin with the simplest one-way device, the diode. A diode allows current to flow in only one direction. Forward, it conducts. Reverse, it blocks. This is why chargers convert AC to DC, why LEDs glow, and why circuits stay protected when a battery is inserted incorrectly. But we're just scratching the surface, because the real superhero of electronics is the transistor. A transistor can act as a switch or an amplifier. A tiny input controls a bigger output, like using your finger to push a much larger door. Give a small signal, the transistor opens and lets current flow. Remove the signal, it closes and stops everything. This ability to switch on and off instantly is what makes transistors the fundamental building blocks of computers. One transistor, a simple electronic switch. Billions of transistors, a microprocessor. Every calculation your device makes comes from transistors switching on-off at mind-blowing speeds. And when you combine transistors in specific patterns, you get logic gates, the brain of digital electronics. A logic gate takes input signals and outputs either a 0 or a 1 based on simple rules. AND gate outputs 1 only if both inputs are 1, OR gate outputs 1 if any input is 1. NOT gate flips the signal NAND, NOR, XOR combinations with more useful behaviors. String these gates together, and suddenly you have adders, memory cells, processors, controllers, entire computers, all built from diodes, transistors, and logic gates, all built from semiconductors. This is why a smartphone has more computing power than old supercomputers. This is why solar panels work. This is why LEDs glow. This is why digital clocks run, TVs display images, cars sense obstacles, and robots make decisions. Semiconductors aren't just important, they are modern technology. Now here's the curiosity to take forward. If all digital logic is made from simple on-off switches, how does a computer store information, remember it, and perform complex tasks like AI and graphics? That takes us into memory systems, processors, and digital architecture, where these tiny switches become entire worlds of computation.